Okay, so we're going to be working on the first lesson of our new unit. Most of the unit is going to be about graphing, so we're going to be looking at areas and volumes, and this first section deals with the area between two curves. So we're going to start with a little review. You're probably going to want some markers or colored pencils or different colored pens or highlighters. So you might want to pause the video and get those. So I'm actually just going to start with the graph in the middle here, f of x, and I'm going to sketch a graph that we pretty much already have done before. So we're going to draw an upside down parabola. It doesn't have to look exactly like mine, just has to be kind of close. And we're going to label a region between A and B, and I'm going to shade that region in. So what we've been doing is we have been using an integral to represent that area, right? So we have our function and we have the boundaries A and B here. And to evaluate that, we took the integral and then did top minus bottom. Okay, so now I'm going to draw a g of x graph, and I'm going to have this be a parabola that opens up. And I'm just making up an example here, so your graphs could look like anything. Mark that off from A to B, and I'm going to use a different color, and I'm going to shade that region in. And we would solve that the same way. We would take our boundaries, and then we have our function. Now what we're going to be doing is combining two graphs together. So I'm going to take the f of x graph and combine it with the g of x graph. I'm still going to mark off from A to B. Now, if I want the area in between, so I'm going to shade the area in between those two graphs from A to B. What I would do is I would take this whole area, so all of f of x, and subtract out the bottom part, the area under g of x, and that would give me the area in between. So this is how we're going to come up with this integral right in the beginning here. We're going to take the integral from A to B, and we're going to do f of x minus g of x. Now I like to remember it as top, the function that's on top, minus the function that's on the bottom. Okay, so let's look at an example. One of the more important things about these is to make sure you have a graph that is correct and accurate. If we look at number 1, we have y equals x squared plus 2, y equals negative x equals 0, and x equals 1. And we want to find the area of the region bounded by all those graphs. So first thing we're going to want to do is sketch a graph. And you can use your calculator to help you. So I already have them plugged in, the x squared plus 2 and the negative x. And if I go and hit graph, I'm going to work on drawing my sketch here. So I have the x squared plus 2. I have the negative x. And I have two more lines here. I have x equals 0. And we have x equals 1. So I'm going to find the area bounded by all 4 of those lines, and that ends up being this area right in here. So I'm going to shade that in. So if you make a nice, clear, and accurate graph, then solving it with your calculus will be a lot easier. So now I'm going to set up my equation. I want to find the area of that shaded region, so I'm going to find the integral from A to B. So I have to find my starting and stopping point. So the graph starts at 0 and ends at 1, so 0 to 1. And we're going to do top minus bottom. So if I look at the top part of this shaded region, the top part is bounded by my x squared plus 2. minus the bottom part of my shaded region is bounded by that line -x. So there's my setup. Now I'm going to clean this up a little bit. This is x squared plus 2 plus x dx. And I'm going to now solve it just like we've been solving before. We're going to go from left to right, taking the integral. So I'm going to add and divide. So that's 1/3 x cubed plus 2x plus 1/2 x squared. And we're going to evaluate from 0 to 1. Next step, we're going to plug 1 in. So I'm going to plug 1 in for x. Minus, we're going to plug 0 in. Now, if I think ahead, I know if I plug 0 into all of these, I get 0 back. So really, all I have to do is evaluate this right here. So that gives me, oops, sorry, dropped my calculator. That gives me 1/3 plus 2 plus 1/2 so that gives me 17/6. Okay, so let's check this on our calculator. So we actually already have the graph drawn. So I'm going to go to my graph and I'm going to calculate. So anytime I want to calculate something on a graph, I'm going to go to second trace. We're going to go down to the integral, number 7, and I'm just going to tell the boundaries. So I'm going from 0 to 1. Now, I wanted to show you this because on a graph, your calculator doesn't understand that it wants the difference between the two curves. It's actually only going to find you that top part, that parabola. So your calculator isn't as smart as you want it to be. It might work on the Inspire. I haven't checked it yet. But what we're going to want to do is go to our main screen and we can calculate this. So with these ones, we can't do a graph. So hopefully you've been practicing using the main screen for your integrals. Sorry if my lights are reflecting on my calculator. So we're going to go to math on the main screen. Shift it like this. We're going to go to number 9, function integral. And we're going to type it in exactly how we wrote it on our paper. So we've got a boundary of 0 to 1. And I'm going to plug in x squared plus 2 plus x, and then over here I'm going to label it with a dx. Press enter, and math enter, enter. To convert our decimal to a fraction, I get 17/6. Okay, so let's try one more. So again, we want to be very careful and we want to make sure that we draw nice graphs. So let's start with number 2. I'm going to get my calculator ready and I'm going to plug those functions in. I have 2 minus x squared and then I have x, so I'm going to get that graphed and then I'm going to draw a sketch on my paper. So I've got an upside down parabola and I've got x. Now, there's an important thing to think about. So we want to figure out where this shaded region is. So it's between the two graphs. So it's this little section right here on my calculator. But I don't know where the shaded region starts and finishes. So what I do need to find is the intersection points. So there's two things we could do. We could use our calculator to find where the two lines cross, or we can use algebra. Now, if we use algebra, we're going to set our two functions equal to each other and we can solve. So I would move everything to one side. That gives me 0 equals x squared plus x minus 2. We can factor this. And I get two answers. I get x equals -2 and x equals 1. Which means my graphs cross at -2 and 1 on the x-axis. Now in our calculator, we can do the same thing. We can go to second trace, intersect, first curve, second curve, take a guess. So I get the 1. I can do the same thing again. First curve, second curve. I'm going to scroll over to this other point here, and that gives me the -2. So I know my graphs cross at -2 and 1. So when I'm going to sketch this, I'm going to be careful, make sure they cross at those 2 points. Doesn't have to be beautiful, but you can try your best to make sure it makes sense. I don't know why I drew this dotted, so I'm going to make that solid. Okay, and let's shade the region in between. Okay, so I'm also going to label my endpoints, my boundaries, -2 to 1. Okay, so let's set this up. We have the integral, so the area is equal to the integral from -2 to 1 of the function that's on top. So the function on the top part of this shaded region is the parabola. So 2 minus x squared. Minus the function that's on the bottom. So minus the function on the bottom is x dx. And remember, the dx is just a labeling. It's saying that you're taking the integral with respect to x. Okay, so now we're going to take our integral. So I'm going to add and divide all the way across. So that gives me 2x minus 1/3 x cubed minus 1/2 x squared. And we're going to evaluate from -2 to 1. Okay, now we're going to do top minus bottom. So I'm going to plug the 1 in first. Minus, I'm going to plug the -2 in second. And now we're going to solve. So I'm going to solve this part, and I'm going to solve the bottom part. And then I'm going to remember to subtract those 2 numbers when I'm done. So I'm going to go to my calculator, let that do most of the work for me. So 2 minus 1/3 minus 1/2 gives me 7/6. And now I'm going to do the right side. So that would be -4 plus 8/3 minus 2. So minus the 10/3. So that's 7/6 plus 10/3. That gives me 9/2. Now, I'm always going to check this on my calculator. You never know if you make a little algebra mistake. So on my calculator, I'm going to go to typing in the original function here. So I'm going to go to math, number 9, function integral. And we're going, the boundaries were -2 to 1. I've got 2 minus x squared minus x dx, press enter, and I did get 9/2, which is 4.5. Okay, so this is the first lesson, so make sure if you have any questions, you go back and rewatch the video. You can also let me know if you have any questions. Colors definitely helps, and it helps you keep track of the boundaries. So it probably is a good idea to grab colored pencils or markers or highlighters when you do these types of problems. It also helps to keep track of like your top minus bottom when you get to this point too. A lot of times people make mistakes in this area because they either forget to distribute the negative or they forget to do one of the halves of the problem. So most of the time people can do the calculus part, the setup, it's the solving of the algebra. So that's why you always want to check on your graphing calculator too, because if you don't get your answer to match, it's most likely a mistake you made with your algebra.